warm welcome online. I think the bulk of our audience is actually online. So hello, and please engage in discussion after the seminar. It's our great pleasure in our ICEDS Energy Seminar Series to welcome Dr. Sebastian Tebbe. He is Associate Assistant Professor, Senior Lecturer with the University of Melbourne Economics Department. He previously did a postdoc at UC San Diego, and the paper that you're presenting, I guess, comes out of that work at UCSD as well. Previously, I think your PhD was done in Stockholm, wasn't it?
That's right.
And then undergraduate economic study in Germany, which is the reason that Sebastian and I are speaking in German. Listening. Okay, we have up to an hour here. And so, Sebastian, I would encourage you to keep the presentation to some period of time that allows sufficient time for an in-depth question and answer session. And really, with that, over to you.
All right. Thank you so much for the introduction. I'm excited to be here. This is, I think, the first time I'm presenting this work outside the US. So I'm very new to Australia. So forgive me any kind of comments about the Australian setting. This will be entirely about the US. So this addresses problems about the kind of second wave of adopters of electric cars who are not able to charge at home anymore, but primarily charge at the workplace. And our main goal with this kind of work and other work that studies the electric vehicle charging at the workplace is to understand human behavior and how to nudge people to charge at the workplace and try and shift their timing towards the day. So this work today is about electric vehicle charging, where we use experimental evidence on incentives and environmental nudges. I almost don't think I need to give you an introduction of why this is important. But the average petrol car, at least again, this is data from California, emits around 5.06 metric tons of carbon per car per year. If an electric car, again, we're speaking about averages here in California, is charged during overnight, it still emits around 1.2 metric tons annually per car. So it's a substantial reduction, but to go all the way, another important step is to charge your electric car during the midday when carbon emissions are the lowest. Again, on average, if we compare those numbers here, the CO2 emissions of a car that is charged overnight is 1.21 metric tons, and during the day it's only 0.26. So we would face a significant reduction if everyone charges during the day, and as most of you are at work during that time at the workplace. So why is this so important? I mean, here in Australia, the EV take-up is still quite low, and the first wave of adopters are mostly homeowners who have their own charging place. But as more and more people adopt electric cars, more and more of them will live in apartment buildings, apartment complexes, or multi-dwelling buildings and don't have access to their own EV charging. So they need to rely on public charging infrastructure, specifically the workplace. So here we basically simply plot the number of people who have access to home charging and the number of people in California who will have an EV. So by 2035, the Californian government expects around 8 million people to own an electric car, and only 2/3 of them will have access to home chargers. So 1/3 of them will require workplace charging as their primary charging option. So we need to understand their charging behavior and how we can incentivize them to charge at work, as this will go into the decision of whether to adopt an electric car in the first place. Why is this timing so important? And here's a bit of an overlap with Australia. So the net demand here, so the consumption minus the solar production in the previous years have shifted more and more down. So this is the infamous duck curve here, where we observe that the net consumption is going negative. That means that we're facing curtailment. Anecdotally, California is even paying Phoenix, for example, to take care of some of their solar generation during the day. So it's quite expensive for California. It's a waste of energy. And this is important for California to reduce this kind of curtailment. And as transportation or as more and more people adopt electric cars, we can charge more and more during the day and kind of shift this duck curve upwards a bit. So here the focus of this paper specifically now is how we can use experimental evidence to shift or to use environmental nudges and financial incentives to shift people's charging behavior to the workplace and during the day. So we make 3 contributions in general here. So we built this environmental basis for workplace EV charging. This is the largest workplace EV network in the US and by far the largest experimental setting out there at the moment. And we're the first to look at the relevance of the timing of charging. Again, this is so far only important in places like California or Scandinavia, where EV adoption is high. But we believe that in the future, with the second wave of adopters coming in, this will become more and more crucial. And at the very end, I speak a bit about the different mechanisms that explain these temporal shifts. And the last part is about the policy implication, which I will not focus on today as much because it's more relevant to the US setting than to the Australian setting. So to give you a bit of a preview of the results here. So what we find is that charging discounts, they led to an increased total energy on campus and longer charging durations. However, these incentives induced opposite temporal shifts. So what happens if we tell people that they should charge during the day instead of overnight? It does induce people to shift to charge more at the workplace, which is quite nice, which basically means that institutions can nudge their employees to or inform them about the environmental damages of home charging, and you see a shift afterwards. The effect of discounts is a bit more complicated. What we observe with financial discounts to charge on campus is that people initially shifted to charge on campus. More and more people charged early on, and it kind of created a horse race to arrive early at the campus. And given that there's a scarcity on our campus or on the UCSD campus, it basically led to people simply showing up earlier or even overnight, which was detrimental in terms of the CO2 emissions. So providing financial incentives for EV charging, at least at the workplace, doesn't seem to be super effective to reduce CO2 emissions. So we derive at least 3 classes of mechanisms that could explain these results. And one is the quality and the scarcity of the network. We observe these shift mainly because the network or because chargers are scarce on campus. So that's the main reason why people fight for these charging places early on. And secondly, the quality of the charging network for public chargers is quite poor. On average, and again, these numbers are all from the US, only 75% of public chargers work. If this is your, and on UCSD campus is 80%, so it's relatively high, but despite the fact that, despite the high quality of our charging network, we still observe people who do want to shift, but the unreliability is a main driver of them not to show up on campus early in the morning. And then I think a second mechanism, which is quite new in the literature, is that financial incentives themselves, in the absence of the financial incentives, create some kind of competition or scarcity. If I tell Frank there will be a discount for the majority of people here on campus, he's likely going to show up earlier, independent of the financial incentives. It's just that the financial incentives create potential scarcity. He believes that other people show up earlier as well. So basically what it means is that these incentives induce some scarcity concern of people themselves. So that's why it's not ideal from a workplace perspective to provide these incentives. And finally, we show that who are the drivers who respond most to our treatment? It's the ones that are quite flexible and have convenience in their home charging. Meaning that if you show up to campus every day, then you're more likely to respond to our incentives simply because you can pick whenever you want to charge your car. If you only come once to campus per week, say, then it's harder for you to rely on this as your primary source of charges. And then again, we derive these policy implications. I think the main takeaway is that these environmental nudges can lead to a permanent CO2 reduction, whereas these financial incentives, they induce an opposite shift. More people charge early in the morning, but we also see people charging overnight and leave their car here on campus and walk back to the house. This happens especially among people who live close to campus. So it actually induced an opposite shift in carbon emissions as a response to these financial incentives. I don't want to talk too much about the literature here. I think what is very novel about our approach here is that we are the first to address this kind of workplace EV charging instead of focusing on home charging. This is a setting with the largest EV charging network, and we're the first to kind of study how we can induce a shift towards workplace charging and towards charging during the day. So I think this is our main contribution here. All right. So now I want to give you a little background information of what we specifically done here in our experiment. So again, our goal was to promote daytime workplace charging, and we run 3 experimental interventions. So the first one ran over 19 days, and we basically just told people what I told you on the first slide. What are the environmental damages from charging at home versus at night? And then we gave them information about their specific CO2 emission reduction when you would shift from overnight charging at home to campus charging during the day. That's the entire environmental nudge. And we told them about that, I think, 3 times. So each week on Monday. The second are financial discounts for workplace charging. So we provided financial incentives for workplace charging over 27 days, irrespective of time. So if you charge on campus, you received a substantial discount to charge on the workplace. And because we believe that these scarcity concerns are one main driver of our results, we designed a third experiment that solely investigated these scarcity concerns. And what we find is that just giving out financial incentives creates as much of a response as the scarcity themselves. So just because, say, ANU would tell everyone that there are financial incentives for charging, this response is as large as just the driver scarcity concerns. So scarcity, at least in a congested network, plays an immense role for workplace charging. And our entire experimental setting will be here at UCSD. UCSD has around 331 chargers. They're going through a massive expansion at the moment. But at that time of the experiment, it was 331, which is quite large. We had 5 different campus zones, and I don't know how many departments were part of this. And we collaborated with the 2 leading charger vendors, ChargePoint and Powerflex, who collect and share all their charging session data. And to run these experiments, David created a campus club called the Triton EV Chargers, which is open to everyone affiliated with UCSD, so including students, faculty, staff, etc. They had to opt in and then consent to the research and then respond to some socio-demographic questions and then receive this consent campus charging. So this is very brief. This is the environmental nudge that drivers received, at least half of them, the treated ones. So here we just try to visualize kind of the avoided CO2 emissions, the unburned gasoline, and the prevented global environmental damages. So this is what you received every Monday for 3 weeks. We wanted to test whether this induces a shift in behavior. And then we created 2 phases of financial interventions. So during the first phase, we gave participants a small discount, so 16 cents per kilowatt hour. So this is roughly 50% of the campus charging rate of, at that point, 30 cents. And this was then equal to the cheapest overnight home charging. So the people in the control group faced overnight charging. The people in the large treatment group faced marginal prices of electricity at that point. So we compared the treated and control group here. The treated group is the one that faces marginal prices. The control group is people who faced overnight home charging prices. And then to see whether this behavior persisted even after our intervention, we created a follow-up financial incentive discount where some of the people remained on the large discount and some shifted to the small discount. And this allows us to test for habit formation. So the people who shifted their behavior earlier, who just wanted to see if you don't give them the discount anymore, do they stick to their charging behavior habits then, or do they revert back? So this is the structure of our study population here. So during the first phase here, in total we had around 629 drivers, and And again, this is by far the largest workplace experiment so far. I think the largest up to that point was 160 in the home charging setting. So it's quite costly to get people to charge on campus and to create this kind of club. So in the first phase here, intervention 1, these 315 people received an environmental prompt, and then 340 people didn't. In the second phase, we sorted people into the large and small discount in order to test whether financial incentives actually shifted people's total charging behavior on the workplace and the timing of workplace charging behavior. And the third intervention, again, is to test the presence of habit formation. Do people remain on their new charging habits, or do they revert back? So this is kind of our outline of our experimental design. I think I mentioned most of it, but we combine various data sets here. So we have this charging network data of PowerFlex and ChargePoint. They provided data about session duration, charging duration, idle duration, energy consumed, etc. We did some sample restrictions. So sessions that indicated an error who are less than 5 minutes, we excluded them, or who flew campus parking rules. So people who park longer than 16 hours because they don't really indicate any real charging sessions. We combined that with driver data. So if you join this Triton Charger EV Club, you had to give us some information about your demographics, about your vehicle, your charging behavior, and your commuting patterns. And we kind of used that for our mechanism part. In addition to that, we asked people about their bi-weekly odometer readings to understand whether people changed their driving behavior as a response to this. A potential reaction to this, which is called the rebound effect in economics, is that people may respond by driving more if they receive discounts on the driving behavior. We don't find that happens here, but we still want to test whether people kind of change their commuting patterns. And then we combine that with home charging rates, which was set by the local utility company. In this case, this is San Diego SDG&E, emission factors, and these will mainly be used for the policy implication, which I'm not going to focus on today as much because they are somewhat more unique to the Californian setting. To give you an idea about our data set then, or about the participant characteristics and charging characteristics, here's a summary of our different data sets, or of our data set. So these may not be representative of the US population, and this is in dollar terms.
Certainly.
But it is representative of people who own electric cars in California. So again, this is still the first and second wave of EV adopters. And again, we're looking at people on average age of 38 with an average income of $135,000 and 17 years of education. Again, we're here at the UCSD campus, and our idea is to study a group of people who adopted electric cars early on. And this is representative of these people. Again, and all of these people own vehicles with an average age of 2 years. The majority of these cars are battery electric, 25% or 24% are plug-ins. And yeah, people show up to campus around 3.5 times. They drive 36 miles per day, and 60% of them have access to home chargers. As a comparison, I think currently in California, around 85% have access to home chargers. So here we're looking at a sample that's the only main difference compared to average people in California who on average have less access to home charging because they rely to some extent on the UCSD charging network, and the average charging price was around 18 cents per kilowatt hour. I saw there was a question. Shall I respond to that now, or shall I leave that for later?
You'll go.
Oh, sorry.
That's okay.
Yeah, because now otherwise I'm going to go into the empirics if there are questions. So the final part is the outcome variables. These are the variables that we're testing. So we're testing how much you share on campus, how often you charge per week. So on average, people charge 1 time per week and consumed around 20 kilowatt hours and stayed for around 6 hours. So these are the outcome variables that we're interested in besides the timing. How do I see the question? Sorry. Okay. Do I have figures for Australian CO2 emissions? Yeah, it's not part of my slide deck at the moment, but I do. And then is there? Yeah, that's a good one. Yeah, I postponed that question. That's a longer response. Yeah, I am happy to provide the Australian CO2 emissions. The other, let's postpone that until the end when I'm walking through the entire statement. Oh, sorry about that. All right, thanks. Okay, very briefly, I have to put some economics in here. So we simply run a simple regression of our interventions on charging behavior. So what we do is we regress the coefficients of our reward treatment and the informational treatment on the different charging outcomes of interest. We control for all the demographic characteristics and garage fixed effects, because you may expect that people at different departments behave differently. The coefficients of interest here, what we're after, are the responses to how people respond to the informational treatment and to the two financial treatments. And during the second treatment, I will compare people who were on a large discount compared to people who were on a small discount to test whether there's some kind of habit formation. All right, so these are the raw results here. So no regressions yet. So the blue line here in the red line here during the first 19 days corresponds to the informational treatment, and the blue line to the control, similar for the financial interventions. I think what we observe here is somewhat frustrating when we first analyzed the data. The only significant effect we could see here, at least visually, was that the people doing a large discount very initially charged a tiny bit more at day 19 to 23. So it created an initial response of people to come to campus and charge a bit more. But overall, the total number of charging sessions remained relatively stable across these treatments. So the implication is basically giving out financial incentives to drivers doesn't charge the total amount that they charge on campus. So providing financial incentives and even giving out environmental nudges doesn't charge how much you charge on campus relative to home charging. The results look pretty similar for energy as opposed to total number of charging sessions. And here we find a tiny increase again after maybe 25 days in the charging time. So I think the main takeaway is here that using environmental nudges and financial incentives to shift from home to workplace charging seems to be infeasible with incentives and environmental nudges. So kind of creating a shift from home to workplace charging seems particularly challenging. So even providing massive financial incentives doesn't seem to help. These are just the underlying regression results. However, what we do find is that these, go ahead, sorry.
Yeah, maybe while you're on the daily charge sessions, is there like a weekly pattern there? You got weekends in these sessions? Do you see a change?
Yeah, so on the weekend, people tend to charge much less, obviously, and before major holidays. But besides that, there's no significant change. Maybe we see that here. Here, this is the number of charging sessions, and usually you see that 2 days, exactly take, for example, day 30 and 31, they see a massive drop, exactly the weekend. But on average, I mean, this is the next charge. This is the average energy per charge that remains still relatively robust, but the total number of charging sessions, they go down. I think there was one public holiday around day 40. Yeah, so around day 40, you see this drop of 3 days. But yeah, people don't charge as much on the weekend, but there's a hospital on UCSD campus and students, so there's still some people charge on campus even during the weekend, sorry. Yeah.
What were the average charging times?
So average charging time was 318 minutes, I believe. Did we double check that? 318 minutes. So here the session duration on average was 380 minutes. The charging time was 233, and 85 minutes were idle time. So that's another problem that we're trying to tackle and follow up work. I mean, it's a fairly congested network, yet people still idle on these chargers. And kind of UCSD has incentive to kind of reduce this idle time. I mean, Tesla, for example, has massive charges if you only idle like more than 10 minutes. I think it's in the US, it's $1 per minute after 10 minutes. And so this is something we're trying to address. But on average, people charge or let their car charge for around 6 hours. Yeah.
You want to get back to this, but I've seen a lot of point to having managed charging throughout the day and then wanting people to be connected throughout the work day. Is that necessarily?
Yeah, so that's a great point. So PowerFlex has automated load management. So you plug in, and then you just tell it that you want to charge throughout the day. So you're going to be there for 8 hours. So it uses the hours with the lowest CO2 emissions. ChargePoint doesn't have that. So there's an incentive for people just to plug in during the day and leave the car at the workplace. Again, we want to incentivize people to come to work, and this was quite challenging. So from that perspective, environmental nudges and financial incentives don't help. They do actually quite the opposite because people charge more overnight. However, I mean, a lot of chargers don't have that yet. So trying to force people to charge more during the morning is helpful.
Surely the convenience of having being able to leave your car for the entire workday.
Yeah.
As opposed to having to go and collect your car, leave it, find another parking spot.
Yeah. So again, this is also has to do with parking, camping, with parking routes on campus. So depending on the location on the map, on the where you work, you can only stay for 4 hours. Some you can stay for 12. So yeah, I mean, we argue later on that one driver of these results is the convenience, as you call it. I think ultimately our vision is that having people plug in the morning with automated load management with a level 1 charger is completely sufficient. But this is outside the scope of this study. But again, I think the first step is trying to understand how people would respond to these treatments and bring them, change their behavior from home to workplace charging. And that seems to be fairly complicated just with these incentives. So before I start talking about the timing, so brief summary is that these financial incentives and environmental nudges don't seem to change much in terms of total workplace charging. And this is consistent with earlier literature that finds like incentivizing people to charge less at home is complicated and financial incentives don't seem to work. However, what we do find is that we provided environmental nudges to charge more during the day. And this is exactly what we see here. So here you see on the left-hand side, you see the charging sessions, the number of charging sessions per day per driver on average. And on the right-hand side, you see the energy consumed. So these bar diagrams here, so the darker blue one is the information people, so the ones that receive this financial incentives, and then the control group. And what we find is that the main difference comes between hours 6 and 7. So people, instead of showing up very early in the morning at 6, they showed up a tiny bit later. And then you see that the energy consumed, which is the this line here, shifts a bit more upwards during the day. This is a tiny response, but I think it's around 4 or 5%, but still it's quite easy to shift people a bit more to charge during the day and shift the total energy consumed to hours at between 9 and 12. So kind of the main takeaway is that information campaigns about why charging at the workplace during the day is important could at least mitigate some of these CO2 emissions. And again, we're speaking about a network that's highly congested. These effects are much larger for places where campus has more chargers and where we have lower congestion. We find the exact opposite of the first financial discount. So again, I said earlier on that these financial incentives created a horse race to charge early in the morning. And again, the bars represent when the number of charging sessions and the line represent the total energy consumed. And here you see that on average, people started showing up at 5 in the morning to secure a charger. And that shifted down over the week. So I have this by week. In the first week, it's less severe, but then every week, people showed up earlier and earlier. And here you see that the main difference comes from people plugging in at 5 in the morning and also overnight. Here you see past 9 p.m., people start to plug in. And what happens, again, these are the lines, what happens is that the energy consumed during the day, which is this darker brown line, increases during the day, That's the large, increases during the day, which is increases over the night, which is not really beneficial in terms of CO2 emissions.
Sebastian, what is it with people in California getting up so late?
All late. I mean, we're talking about a different set of people here, right? I mean, we're talking about a combination of people here. I'll explain a bit to that later on. We're looking at students, medical workers, ambitious professors who respond quite strongly to these incentives. So 5 in the morning, what we find is that these are like high earner professors. Overnight, these are medical workers and students. So students just drive to campus, leave their car there, and then we don't know how they get home, but we see that their car is plugged in overnight, and then same with medical workers. So we have different responses from different groups here.
Ever seen an academic at 5 a.m.?
Well, before our intervention, there was no one plugging in at 5. But if this is your only option to charge, again, if this is your primary charge, you don't really have an alternative. Yeah. And who are the people who respond to the stream? It's people who show up 5 times per week to campus. So it's the ones that really rely on these charges. So there's no other option for you to either charge at night, again, in a highly congested network. Again, and that's why it's, talking about the quality and the number of chargers in workplaces will become more and more important the more people adopt electric cars. And again, we are here in Australia at the first wave of adopters, but the more people with apartment buildings, living in multi-dwelling buildings adopt electric cars, the more important this will become. So this is the test for habit formation. So again, we have the same kind of treatment. The only difference is that we shifted some people from receiving a large discount to the small discount to test what happens. And what we see is that the people who stay on the large discount, so who had a longer extended period of large discount, they increase their charging sessions overnight and even early in the morning. So what happens is that these financial incentives, the longer you give them to people on campus, the more extreme the responses will be. They even plug in now at 8 o'clock overnight, and then they shop even earlier. So I think the longer you let people, we describe this in our paper as a horse race. The longer you leave these financial incentives or give these financial incentives to people, the more severe their responses will be. And like 7, 8 o'clock is basically when people leave campus, keep their car, and then plug that in. These are our main takeaways. These are the underlying regression results, but they're just a summary of what I just tried to explain. I think we have really nice additional results. So we do this week by week, and that's where we find that that the response in the first week is quite high among the treated people, but then the control group also charges early in the morning. So what basically happens is that people who receive the large discount, they shift early on to early morning charging, and then the control group to secure chargers, they charge early in the morning as well. We don't find any increase in total mileage or energy consumption, so people don't respond by driving additionally, except one person who started driving for Uber, anecdotally. So then we also don't find any kind of substitution effects. So you could imagine that people charge more on the weekend. I think someone asked that. A potential response, because the network is less congested, is that people charge more during the weekend when the network is less congested, but that doesn't seem to be a response here. And we find similar results on clean air day. So this is a day in California where all kind of green behavior is incentivized. They also tend to charge earlier during that specific day. So when the university gives us incentives to charge on campus. All right, how much time do I have left? Let's see. Okay, let me go through the mechanisms, and then I'm happy to respond to all the questions. So we spent a great deal amount of time to understand what could be the potential mechanisms here that explain our story. And we came up with 3 clusters of results. So the first one, and I think this is the most severe one that we're trying to address in follow-up work, is the network utilization and the charger reliability. I try to convince you on the next few slides that this high network utilization and the low charger reliability are the main reason why we observe these shifts towards evening hours and very early morning sessions. Secondly, I think what is often forgotten in the literature is that financial incentives, if you provide them, themselves induce some kind of scarcity concern. If I receive a massive financial incentives and I know that all my coworkers receive them, then I'm going to change my behavior simply because of that scarcity concern, not because of the financial incentive themselves. So what we're trying to look at is whether just telling people without giving them financial incentives induces their behavior. And that's exactly what we find. And finally, we look at the different characteristics of drivers that may explain these temporal shifts. And I think someone earlier mentioned the convenience of home charging and the flexibility of commuters. Those seem to be the main characteristics that explain these shifts. Why is that important? I think this can be used in two ways. One, you can basically predict, depending on your charging network, what kind of temporal shifts you can expect. And secondly, you can target interventions towards groups that are most responsive. So if you target to groups that respond in their behavior, this is more money for your bucks, basically. So there's no point for it. I mean, as one example, we asked them prior to our interventions about environmental damages of charging with respect to the timing. And I think less than 5% had any idea how carbon emissions look like throughout the day in California. Obviously, people working in this field, like environmental econ, they did know. So targeting these interventions towards these people seems like a waste of money. Instead, informing people who care about the environment and who are unaware of this is more cost efficient. This is, I think, our main takeaway. All right, so these are our 5 campus zones. So this is and the hourly charger utilization. So here you see the share on an average weekday by hour, how many chargers are occupied. And in almost all of them at 8, 9 o'clock, it's, say, on average 80%, which means that on an average day, 4 or 5 chargers are occupied early in the morning. I just want to mention that this includes public holidays, for example, and it excludes vehicles that just park on those spots that we can't observe. So we had a research assistant having to go around to see whether blocking these charging spots is actually a potential problem. And a lot of people seem just to be happy to pay these fees or like, just parking on these charger spots without charging. So that's the ones that we don't observe. If we use data, or if we use our own data, these effects on an average work day are close to 100%, at least on East and West campus. Graduate housing is a bit different. That's where all our graduate students, or not all of them, but quite a few of them live. There we don't observe this massive upward shift early in the morning. All right, now this graph at the beginning looks a bit more complicated, but I'll try to break it down. So what we find, our main effects are these hollow diagrams. So we see a shift, reduction in early morning charging of the environmental nudge in the first graph. We see this shift of early morning and evening sessions in the first financial discount, and we see the shift of even evening sessions a bit earlier on during the financial discount. So what we are trying to do here is we're trying to understand what characteristics explain these shocks. And I think our main takeaway is that during the second and first financial discount, people who park primarily in medium and high utilization zones, they are the ones responding to this. So what this graph tells you is that the people who would charge at medium and high utilization, they are the ones responding to that financial discount here. And then quite the opposite for the environmental nudge. Who are the people who respond to the environmental nudge? It's the one who are primarily in the low utilization zones. So I mean, why is that? Because I only respond to an environmental nudge if I know there will be free parking spaces later on during the day. I shift to later parking because I expect there will be parking spaces. This is probably unlikely going to happen if there's a full parking spot. So again, main takeaway from this graph is that if you provide environmental nudges, they only seem to be efficient in places where there's not fully congested network, which seems reasonable. And then secondly, who are the people who respond to the financial incentives by charging at night. These are the people who face high utilization zones. So if I know that my parking spots are going to be occupied next morning, my only response is by charging the night before at these campus zones and leave the car there for like 24 hours. And then, I mean, again, I was shocked by the statistics. I couldn't believe it initially, but in our case, only 80%, roughly speaking, of charging sessions delivered a meaningful energy of more than 0.5 kilowatt. So 20% of charges initiated some kind of error. And that could be due to many factors. So for example, app connectivity, the charger is broke, and yeah, potentially fluting some kind of rules. Anyway, 80% of charges didn't deliver a charge. And if you plug in, and these are to vendors here, if you plug in and it doesn't deliver, or the operator doesn't deliver a charge, then your likelihood of charging becomes much lower. So if you're unhappy with the charge and you try once, and then you try again, you become less and less likely to charge on campus. So this kind of glitch rates, as we call them, or this unreliability is a massive problem, given that 1 out of 5 charges doesn't deliver a meaningful charge. So we wanted to test whether this explains our empirical findings. And again, no surprise, it does. So what we see again, this is the same diagram. Again, we are trying to fill out these hollow bars. And what we see is that people only in low and medium glitch rate areas, they're the ones responding to our financial incentives. Meaning that you only change your behavior if you know that you can rely on a charge when you show up. I mean, it seems obvious, but these financial incentives, I mean, they are ineffective in a way that they shift towards evening behavior. But if you use financial incentives to change behavior, they only seem to work if your preferred parking lot has high functionality or high reliability. And then finally, or I think this is what I try to communicate a few times now, these discounts induce scarcity on them own. Again, if I provide these financial incentives, they create scarcity that everyone receives these discounts, and that creates some kind of norm of maybe charging early in the morning. And again, what we find here is that these induced scarcity perfectly explain our results. So we see that people with induced scarcity, they're the ones who charge in the evening. So what we did in this experiment, we just told people or everyone of this club that these financial incentives are given out, but it's the same amount to everyone. It just created some kind of scarcity among people. There was no differences in financial incentives, just differences in people who received. So we told one group that only few people received their charge, with the other group we told that everyone received their charge. And the differences in responded basically corresponds to the expectations of how many people will change their behavior, and that explains perfectly our evening responses. Like, it doesn't fill up the entire bar, but it's definitely part of the response. So if you design these financial incentives, we should be aware that the scarcity themselves create a massive effect besides the financial incentives. And then we're trying to understand which driver characteristics are most in line with our results. And what we find is that people
Maybe some of the detail for the discussion.
Okay, then let me finish this on the slide. So we find that people who are quite flexible in their response, who show up to campus more than 3 times per week, they're the ones responding. So it's mainly the people who commute almost every day. I'm going to leave the policy implication because this is mainly about the US and not super interesting here in this setting. But I just want to briefly conclude about the outlook and kind of, again, highlighting why this is so important. So what we've done here, we wanted to understand how to induce a shift towards more daylight hours with abundant solar energy. We used these field experiments to measure the effect of environmental nudges and financial incentives. And what we find is that they create or induced opposing temporal shifts. Environmental nudges led to a transition towards daytime charging, whereas financial incentives prompted the shift towards early morning charges and evening charges. And the policy implications are here quite striking. Simple information campaigns about why workplace daytime charging can reduce CO2 emissions would be quite helpful and reduce CO2 emissions by quite a bit. I didn't show you the results. On the other hand, financial incentives in a congested network seem to be quite detrimental because it induced this kind of scarcity concerns among drivers. And then kind of to talk a bit about the outlook here, grid operators. So the benefits here, we measure the benefits of our experiment and scaled that to all drivers in California. Simply providing information campaigns in California about data and charging would reduce avoided damages by around 252 million. And then to give you a brief outlook, 2.6 million megawatt were curtailed, of renewable were curtailed. This is equivalent of 30 million full charges of an average car, or 633,000 EVs per year. So we could massively reduce this curtailment. And given that the second and third wave of electric vehicle owners will rely more and more on workplace charging, understanding when people charge and where people charge will be quite important. And that's kind of our main takeaway. So policy states should encourage the shift to daytime charging, and simple information campaigns could help with that. All right. Thank you so much for your attention.
Wonderful, Sebastian. I think it really clear, obviously, the results from your paper here. We've got very questions on that. Well, so much. That's great. You can also see it's not good. Yeah, so look, the situation is obviously very similar in Australia, right? In terms of abundance solar during the day, with more and more occasions, especially spring and autumn. Yeah, curtailing large-scale solar. Now that is a good solve, too much solar, and we got to get the EVs charged in the day. And there's almost no price-based incentive to sort of flat rate charging, so on and so forth. Bigger picture question, I'll continue as the first question. On a regulatory level and market design level in California, are there any moves afoot in terms of California or utilities or anything like that to actually go ahead with differential pricing, contracts with EV users, anything like that? Or is it all still at the conceptual?
Yes, I think so far it's mainly at the conceptual end. I think there's some small incentives to charge more during the day, but they're not as large as we maybe hope for. And then on campus, there are no financial incentives to charge more during the day. It's actually quite the opposite. You pay for parking on campus, you usually pay a higher fee during peak hours. So you kind of disincentivized to charge during the day. If you take into consideration that you also have to pay a parking fee when you come on campus.
Yeah.
So currently, I think it's quite opposite. And then historically speaking, there was an incentive to charge over that.
Yeah. And in terms of your experiment, right? So you obviously have a set of chargers on campus that presumably are run by a commercial company.
Yeah, exactly.
And so all you needed from them was the data access. You didn't need them to change. What happened actually? How did you?
Yeah, we, I think this has been a project for a long time now. We started collaborating with ChargePoint and Portflex, who were willing to share their charging session data. And then internally, we created a campus club of EV drivers. So we contacted all affiliates who own and drive an electric car and asked them if they want to opt in and consent to this kind of research.
Okay. And that's how you paid them?
That's how we paid them, yeah.
Curiously named Triton Club.
Exactly, yeah.
Very good. Question in the back.
Thank you. Thank you very much for wanting to walk in this field. I just want to go back to the slide you showed, which had petrol cars and machines up 5.
Yeah.
Then the EV car types, nighttime car 1.2.
Yeah.
And my question is kind of relating to California. I think if you charge electric vehicle from green energy at nighttime, the emissions are much less. So that even if you charge it from fossil fuel electricity, still the emissions are less.
Yeah.
If relevant sized car was driving petrol.
Yeah.
So my question is just simply that 1.2 for the charging at night. Was that specified as green electricity, or was that just what was ever on the grid?
So what we assumed is that the marginal electricity that was on the grid on an average day in California throughout the year. So we took the average type of energy that was on the marginal type of energy that was on the grid, multiplied it by the average miles traveled, and we had extensive data set on average vehicle and multiplied by the average vehicle emissions.
In there, with our hydro.
I don't think hydro was ever on the. I don't think they have much hydro, but hydro was never the marginal source overnight. Yeah.
Quick question. Well, thank you, Ralph. Can you tell me the comparative price for parking on campus and parking your vehicle in an instance?
Oh, so you pay the same price. So parking is similar if you park in the EV slot or in a normal parking spot.
So they close the charge cost?
No. So the charge cost is separate. So say you are a fossil fuel owner, then you only park the parking fee. If you are a EV owner, you have to pay the parking fee, and on top of that, you have to pay the charger. That's why I respond to Frank saying that currently it's kind of you're disincentivized to come to peak hours during the day because then you face higher prices. But this is the complicated part about this is that you have a congestion effect in terms of how many people can park your car on campus, but you also have the emission effect of how to reduce emission from charging, and they go into opposite directions. I mean, that's the complicated bit from a institutional perspective. So the institution has an incentive to increase the prices during the day because there's more congestion. From a policymaker's perspective, you have an incentive to charge more overnight to reduce prices during the day. So we have here two opposing roads here when it comes to emissions and congestion. That's why, in our perspective, follow-up work will be about the network expansion, and we argue that this is crucial for people to come to campus and charge during the day because these financial incentives backlashed, and one reason was the high network utilization and low reliability.
Yes. Yeah. Thanks for that. And it was interesting that the environmental concerns out of the financials.
Yeah.
You see that use of it would be useful if institutions have to report that individual emission load, but they're responsible for the emissions of their staff or students or affiliates that become part of the ESG reporting. And do you think pushing institutions or corporates to move their staff to way the approach?
Could be, yeah. It's an interesting question. I think it's, I guess, similar in the sense that you make people more responsible. Like, people definitely think more about their CO2 emission from their transport. But yeah, whether this, I can only speculate, but whether this would hold in that setting as well, I would say most likely. But maybe providing from a environmental nudges is from a social point might be better. But again, this is speculation.
Got a few questions online. One is from our colleague, Dr. Ben Elliston, who, by the way, is, I think, the president of the ACT Electric Vehicle Association. Question from Ben: is there a risk that EV ownership that depends on workplace charging will discourage public transport during peak time periods? Right. I think that's actually a question that can be expanded beyond the university workplace context.
Yeah.
Yeah, I think in your car charging to bring work, and you're shooting you drive to work.
I think the first best solution is to switch to public transport. This is no option in California. So I think the best second solution is to provide financial, or like to make people charge during the day on campus. So I do agree with that, but in a European setting, there should ideally be more subsidies for financial for public transport. Unfortunately, in the US setting, we work together with the local train company to see whether there's some potential substitution with public transport, but we couldn't find any of them. So yeah, in the US setting, I think the best we can do is provide incentives to charge on campus. In Europe, where there's reliable public transport, that's a good option. I mean, the majority of my work is for Sweden, and there we do find large responses to financial incentives to public transport.
Right.
So this is a really good option. In Australia, I'm less familiar with the setting. I'd expect that there's some response maybe in Melbourne and Sydney where you have reliable public transport, maybe less so in.
Quickly, question from Claire de Castella, who for ANU is responsible for aspects of the campus decarbonization strategy. Claire is asking, can you explain what do you mean by highly congested networks for parking spaces, for charging, or for both? Where is the congestion?
Sorry, I should clarify that. When I speak about congestion, I always meant the total number of parking spots. When I speak about utilization, it's usually related to the charging. In our case, we face both. Like in San Diego, utilization is on average almost 90% on an average workday. So yeah, if that's what I meant.
Not a question from the floor. By the way, I should have said, please feel free to introduce yourselves. I think that's needed.
Go back to your slide in the office with regards to your similar to do with benefits of daytime charging. Mention it on that being stuff with the Greeks and locations by 1.2 in the fund CO2. How did you actually figure out what kind of options you do want?
Well, I have to look at that at those numbers again. Yeah. I'm sorry. Yeah.
I'd encourage you to stay back for a chat. And just before we go, can you tell us about your research plans now that you're in Australia?
Yeah, so
I'm interested to know what's on the horizon.
I mean, I've been here for 4 weeks now. So far, I'm just trying to understand the setting a bit in Australia. But ultimately, we are planning to work with the charging infrastructure in Melbourne. We're looking at not workplace or home charging, but public charging infrastructure. So the ones that you find in malls, they make up around 5 to 10% of the people's charging. But the kind of incentive setting between public chargers and the policymakers' perspective is also way different. The problem is that, say, Woolworth has an incentive to have rich customers come in and charge their electric car. But what you ultimately want is to create incentives for people who rely on public charging as your kind of first best. As a show, not everyone has access to home charging. We're trying to think about, and this on stage, align these different incentives of public chargers and chargers.
Planning to look at vehicle to grid as well. This is something that we have very keen interest in here. The new pilot scheme in the setting.
Yeah, that's again, I haven't done that yet, but I'm curious to find out more.
Anything else before we close? Okay, and as usual, we of course acknowledge the traditional elements of the lands on which we meet. All Malwick people, and have a great afternoon, and thank you for swinging by.
Yeah, thank you so much for having me.